welcome to today's class. This is your online tutor, Mr. Ilaki. So basically today we'll be looking at index notation, okay, under this particular topic. So under this particular topic, we're going to look at index notation, okay, and under index notation we're going to look at indices. First of all, we need to understand what do they say when they say indices. So indices indicate how many times a number is multiplied by itself. For example, when we are given e.g. when we are given 2 multiplied by 2 multiplied by 2, okay, so this is just the same as saying 2 to the power 3, okay. So what we're saying here is we have got 2, okay, so 2 is our what? Our base, okay, so 2 is our base. Then we also have what? Our power, okay, or index, okay. We can call this as our power or the index, okay. So basically we'll be looking at indices. So we're now going to look at the laws of indices, okay. All right, so if we have, okay, m, okay, if we have m, so if we have m can represent any number, okay, to the power x, okay. So our m, okay, so our m, we said our m is what? Our base, okay. Then our x is our power or index. So this m can represent any number. For example, this 2, okay. Then this x can represent any number. For example, this power, which is 3, okay. So now we look at the laws of indices, okay. So the first law is the law of multiplication, okay. So our first law is the law of multiplication, okay, where we are saying if n to the power x multiplied by n to the power y, this is going to be equals to m to the power x plus y. So what are we saying? If we have got the same base, okay, we have the same base. Sorry for that. We have the same base, okay. Here we have the same base. When we have the same base, we what? We add the powers, okay. We add the powers. So we have the same base, we add the powers, okay. So our first example, okay, we have our first example where we have been given 3 to the power 2 multiplied by 3 to the power 4, okay. So what are we going to do in this particular case? Okay, we're going to say we deal with this one first. We're going to say 3 times 3, okay, multiplied by 3 times 3 times 3 times 3. Okay, so this is going to be equals to 3 multiplied by 3 multiplied by 3, okay, multiplied by 3 multiplied by 3 multiplied by 3. So this should be 1, 2, 3, 4, 5, 6. Okay, so this is going to be equals to what? When we add all these, it's going to give us 3 to the power 6. Okay, so where we have 3, we know that 3 we have the same one, the same base. So we add the powers, this one and this one. So we add 2 plus 4, okay, which gives us what? Which gives us 6. Okay, which gives us 6. Okay, so which is equals to 2 plus 4. Okay, so that is the same, that is the sum of the two powers in the original multiplication. Okay, so in the original multiplication, that is the sum. So the other way, okay, if we wanted, we would have just gone direct, okay, by saying 3 to the power 2, just as we did here. Okay, this is how we're supposed to go direct. Okay, so I'll just do this to show you to the power 4. Okay, this is going to be equals to 3. Sorry for that. So 2 plus 4, which is equals to 3 to the power 6. Okay, we move on to the next question. So the next part, we have been given 5 to the power 4 multiplied by 5 to the power 7. So what are we going to do? Okay, we are going to apply this principle where we are saying m to the power x multiplied by m to the power y is equals to m x plus y. So we have got the same base in this scenario. So this is going to be 5. Okay, so we add 4 plus 7. Okay, so when we add 4 plus 7, what are we getting? We are getting 11. Okay, so we get 11. So this is our answer. Okay, then we have got another question, question C. Okay, it states p to the power 3 multiplied by p to the power 7. Okay, so what are we going to do in this particular scenario? So we're saying the base is the same. We simply get one of the first bases, then we add the powers. So we're saying 3 plus 7, which is equals to p to the power what? 10. So basically, this is how we can solve questions on the first law, which is multiplication, the law of multiplication. So the next law is the law of division. Okay, so if we divide a number to a power by the same number to another power, we subtract the powers. Okay, so what we're saying here is that where we have m, sorry for that, where we have m to the power x divided by m to the power y, this is going to be having the same base. We're going to say m to the power x minus y. So where there is division, there is what? Subtraction. Okay. All right. So we have been given a question there which says 3 to the power 4 divided by 3 to the power 2. Okay. So what do we do in this particular scenario? Okay. So we're saying 3 multiplied by 3 multiplied by 3 multiplied by 3 over 3 to the power 3. Sorry, 3 multiplied by 3. Okay. So this will cancel with this will cancel with this, and we are going to remain with 3 multiplied by what? By 3. Okay. So this is the same as equals to 3 to the power 2. Okay. Where we have 3 open bracket 4 minus 2. Okay. So this is equals to what? 2 plus what? Sorry, 2 minus 2. 4 minus 2. Okay. So that is the difference of the two powers in the original division. Okay. So that is the difference of the two powers in the original what? Division. Okay. So this is how we can solve for division. Okay. So just follow this particular formula and you'll be able to solve questions on this particular law. Alright, so we resume. So we have been given our second question where we're told to say 7 to the power 5 divided by 3 to the power 5. So in this particular case, what do we do? Okay, we follow our principle which we have been given to say m to the power x divided by m to the power y equals to m to the power x minus y. Okay, so what is in this particular case, we have our base which is what? Common. Okay, so we get the 7. Okay, then we say 5 5 minus 3. Okay, and we are going to have our answer as 2. So this is how we solve. Let's do the last question. Question C on division of indices. Then I'll give you some questions which you can try out. Okay, we have been given another question where we are saying r to the power 6 divided by r to the power 3. So we apply the same principle. So we're saying r to the power 6 minus 3. Okay, so therefore r is just going to be 6 minus 3 is just 3. So let me give you a task which you can do. I'll write the questions down there. Alright, so you can try to work out these questions. Okay, try to work out these questions and you can give me the feedback. Okay, so try to work out these particular questions. Okay, so you can pause the video, then write the questions down so that you can try to work out these questions. Alright, so we now look at repeated multiplication of numbers raised to a power. So what we are saying is that when we are given m to the power x cross then raised to the power y. So this is just the same as m to the power x y. So x and y will multiply each other. So we can look at an example there. So where we're saying 3 to the power 2 raised to the power 3. So what are we doing in this particular scenario? Okay, this is just saying 3 squared times 3 squared times 3 squared. Okay, so this is equals to 3 multiplied by 3 multiplied by 3 multiplied by 3. So this is just the same as this. Okay, we have just multiplied this. Okay, then so this times this. Okay, we remove the brackets now. Okay, so this is 3 times 3 times 3 times 3 times 3. So this is equals to what? This is equals to 3 to the power 6. Okay, so hence this is equals to 3 to the power 6. Okay, where we are saying 2 multiplied by 3. Okay, so this is just the same as this. So this is equals to this. Okay, so we'll now look at another example. Okay, we look at example B. Okay, example B says 4 open bracket 4 raised to the power 7 close raised to the power 3. So what are we going to do? We're going to apply the same principle where we are saying, I'll just write it on the side here, where we're saying open bracket m to the power x close, then to the power y. This is just the same as saying m to the power x y. So we're going to apply this principle here. So we are saying this is going to be 4 7 multiplied by 3. Okay, so where we are saying this is going to be what? 20. 3 times 7, this is what? 21 as our answer. So another question, question C says open bracket a to the power 3 close raised to the power 7. So we're going to apply the same principle to this particular question as well. So we are saying a to the power open bracket 3 multiplied by 7. So this is going to be what? A. So 3 times 7. Okay, this is just 21. So this is our answer. So this is how we can calculate or solve question on repeated multiplication of numbers raised to a power. Okay. So now we look at zero exponent. Okay, or zero index. Okay. So when we have a zero index, we're saying m to the power 0. Okay, so what is the meaning of m to the power 0? Okay, so we consider when we have m, sorry for that, when we have m to the power 3 divided by m to the power 3. We know that this will give us m to the power 0. So m could represent any number, as I said earlier. Okay, so in this particular case, we know that m to the power 0 is equals to any number to the power 0 is equals to what? Is equals to 1. So we are saying m to the power 3 divided by m to the power 3 is equals to 1. Okay, so hence m to the power 0 is equals to what? To 1. So any number to the power 0 is equals to what? To 1. So even if it's 1000 to the power 0, it's always equals to 1. Okay, even if it's 2 million, it is always going to be what? To be 0. Okay, so we look at some examples. Okay, examples based on this particular scenario or the zero index. Okay, so we have been given our first question there where we're saying 7 to the power 3 divided by 7 to the power 3. So this is equals to 3 multiplied by 7 multiplied by 7 by 7 by 7 over 7 divided by over 7 multiplied by 7 by 7. So this is just the same as this. Okay, so this is equals to, this will cancel, and we are going to have what? Our answer as 1. Okay, or we can say 7 3 to the open bracket 7 to the power 3 minus 3. Okay, this is equals to what? Equals to 7 to the power 0, which we know is 1. Okay, okay, so we have another question on the zero index. We're saying 3 to the power 4 multiplied by 3 to the power negative 4. Okay, so what are we going to do in this particular scenario? Okay, so we're saying this is equals to, we know that we have got the same base. Okay, so we'll add the power. So 3, then multiplication, addition here. Okay, there's an addition sign. Sorry for that. So plus minus negative 4. So this is going to be equals to negative times positive, it's negative. Okay, so we're going to have 4 minus 4, which is equals to what? 3 to the power 0. Okay, which is just any number to the power 0 is 1. So this is all on the zero index. Okay, alright, so now we look at repeated exponent or negative index. Okay, so in this particular case, what is the meaning of m to the power negative 3? Okay, so we consider being given m to the power 4 divided by m to the power 7. So what do we have? Okay, so we multiply the top part. Okay, m times m times m. Okay, then m multiplied by m multiplied by m multiplied by m multiplied multiplied by m, multiplied by m, multiplied by m. Okay, so what we are having is we have 1 over m to the power 3. Okay, so this is just the same as m to the power negative what? 3. Okay, so this is why we're saying, but m to the power 4 divided by m to the power 7 is equal to 4 minus 7, okay, which is equals to m to the power negative 3, which is just the same as 1 over 3 to the 1 over m to the power 3. Hence, we are saying m to the power negative x is equals to 1 over m to the power x, which is the reciprocal, okay, reciprocal of this particular question. So for example, okay, I'll just give an example. When we're given 2 to the power negative 1, okay, so this is just the same as 1 over 2. Or if we're given 3 to the power negative 4, so this is just the same as 1 over 3 to the power 4. Okay, so this is reciprocating. Okay, so the reciprocal of this. Okay, so this is what is happening here. Okay, now we look at fractional exponent or index. Okay, so when we are given, what's the meaning if we are given 4 to the power 1 over 2. This is the question. So we consider that we have 4 to the power 1 over 2, okay, multiplied by 2. So this is supposed to be a 2, sorry. So over 2, okay. So this is going to be equals to 1, okay. When this cancels with this, we're going to have 4 to the power 1, which is just equals to 4, okay. So but we have 2 to the power 2. This is equals to what? 4. Okay. Then we're going to have, then we have 4 to the power 1 over 2. Okay. So this is just the same as open bracket. Okay. So the 2, because of the square, will disappear here. Okay. There is initially a 2 here, but we don't put. Okay. Unless if it was a cublet. Okay. So 4 to the power 1, which is equals to 2. Okay. Hence we're saying m to the power x over y. Okay. This is just equals to what? We have our y there. Okay. Then m to the power what? X. So this is the same scenario here. Okay. So this is what is happening in this particular scenario. Okay, so we'll look at some examples. We'll do some examples based on what we have covered. So we have an example here. Okay, we have some examples. We'll start with the first question. We are told to find the value of. So in this question, we are told to say 8 to the power 2 over 3. We need to find the value. Okay, so we substitute in this particular equation. Okay, so we substitute our 3, okay, here. Then since this we are finding the cube root, then our 2 will be outside. This is x. Okay, so the cube root of 8 is just 2. Okay, 2 to the power 2, which is giving us what? 4. Then question B says 25 to the power 1 over 2. So this one will be straightforward. Okay, so since we are finding the square root, there is no need of putting a 2 here. Okay, so we have what? 25. Okay, we know that power 1 is just so the square root of 25 is just 5. Okay, to the power 1. So 5 to the power 1 is just 5. Okay, then we have another question. Question C. We are told to find the value of 4 to the power negative 1. Okay, so this is the negative index where we are going to reciprocate, and we are just going to have 1 over 4 as our answer. Okay, then we move on to D. Okay, where we have 7 to the power 1 over 3 close bracket, so to the power 0. So this is a 0 index. Okay, so what's happening here? Okay, so this is 7 1 over 1 multiplied by 1 over 3 multiplied by 0. Okay, this is going to be what? 0. Okay, so 7 to the power 0, 0 is just 1. So this is our 0 index. So we know that when any number to raise to the power 0 is equals to 1. So we are using m. So we can use any number. Okay, just like in this particular question. Okay, we now cover question E. So 3 over 4 to the power negative 2. So how do we solve for this question? Okay, so what's going to happen here is we're going to have, when this goes down there, okay, it's going to be reciprocate just like in this particular question we did. So this were prime. Okay, where we are saying when we have m to the power negative x. Okay, this is just the same as saying 1 over m to the power x. Okay, so here we're going to have 3 over 4. Okay, so this is going to be equals to, so when we divide 3 over 4, so which the signs will change if we use the other sign, the multiplication sign. So it's going to be 4 over 3. So we're going to have what? This multiplied by this, it's going to be what? 4 over 3. So our final answer there is going to be one whole number. Okay, remainder 1 over 3. So just like that. Sorry for that. Sorry for the mistake. So after we have reached this stage, the 2 will be here. Okay, so we're saying divided. So 3 multiplied by 3 is 9 over 16. Okay, so we're going to change our signs. So this will come up. Okay, when we change the sign to multiplication, so this is going to be what? 16 over what? 9. Okay, so this in 10, our final answer is going to be one whole number, okay, 7 over 9. Okay, so this is our final answer for this particular question. Okay, then our last question, it says if 25 to the power negative 3 over 2, we find the value. So we apply using this formula. Okay, so we're saying this is going to be equals to root of 2. We want to indicate the 2. Okay, 25 to the power negative 3. Okay, so the square root of 25 is just 5. Okay, to the power negative 3. Okay, so after this we use the negative index. Okay, we apply, so we bring this, it's going to be we bring this down, it's going to be 5 to the power negative 3. So this is equals to 1 over, so 25 times 25 times 25. Okay, so this is just going to be 125. Okay, as our final 1 over 125 as our final answer. Okay, so there is a task for you. You can try to answer based on what we have covered. Okay, so this is a task, so you can pause the video and copy the questions, then you try to answer. All right, now we look at solving the unknown values in the equation that do not have a common base. Okay, so solve the following equation. So we have got our first question, okay, which says A says 8 to the power x is equals to 4 to the power 3. So what can we do to solve this question? So we need to make the bases equal. We need to make the bases equal. So what are we going to do in this particular scenario? Since we know that these are not common bases, so we will find 2. Okay, so we know that 2 to the power 3 is just 8. Okay, so 2 to the power 3 is just 8. Okay, so it's going to be 2 to the power 3x. Okay, sorry, 2 to the power 3 multiplied by x, which is equals to we also find a common base for this one, which is 2. So 2 to the power 2 is just the same as 2 times 2, which is 4. So 2 to the power 2 multiplied by 3. Okay, so we have the same base from here. So we have 2, we have when we multiply this, we're going to have 3x is equals to 2 to the power 6. Okay, so the bases are the same. Now we can solve for this particular equation. Okay, so going to have 3x is equals to what? 6. We divide both sides by 3. Okay, and our answer is going to be what? X is equals to 2. Okay, then our question B says open bracket y to the power 3 close to the power 2 is equals to 8. So in this particular scenario, what we are going to do is sorry, this is supposed to be 2. Okay. So this is supposed to be 2 here. So what's going to happen is we work out this multiplied by this, we're going to have 3 multiplied by 2 is just 6. Okay, to the which is equals to 8 to the power 2. Okay, sorry, we have made a mistake. So what's going to happen here is we have y to the power 3 multiplied by 2. So this can also be written as 2 to the power 3 multiplied by 2. Okay, then when we multiply this multiplied by this is 6. Okay, which is equals to what? 2 to the power 6. Okay, so since this is the same and this, they will cancel, and our final answer is going to be y is equals to 2. So making the bases equal. Okay, so we make the bases equal, or uh, making the bases equal, or the powers equal. Okay, to form the base. Then from there we will be able to solve, just as we have solved this particular question. So I'll give you a task. You can try to answer the following questions. Okay, so try to answer the following questions. So basically, try to solve these questions. You can pause the video and try to answer these particular questions. Okay, so try to solve these questions. So thank you very much. This has been your online tutor, Mr. Ilaki. If you have got any questions, any clarifications, kindly ask questions through the platform.